Please join me in welcoming our panelists. Nufal Ibrahim, our first keynote speaker. Thank you very much. I guess we already know a lot about him by now. I will not I guess his keynote spoke for itself. Then we have tomorrow's keynote speaker, Peter Wang. The CTO and co-founder of Continuum Analytics, now Anaconda. And we have Anand Chittipotu. He's been a long time, again, like Gopal, one of the oldest members of the Python India community. He's been working in web development for a very long time. Recently, he co-founded a company called Roro Data, which specializes in deploying machine learning applications over the web and serverless applications. Then we have our first speaker from today, S. Anand. As those of you who were not here for his talk, please do look it up online. Anand's talks, mostly I've seen them only have like standing room. And I think we already have a hint of where he thinks Python fails. So, all right. And then finally, please join me in welcoming the moderator, Dr. Prabhu Ramachandran, Managing Director of Enthought India, and Professor of Aerospace Engineering at IIT Bombay. There are many ways in which I could introduce Prabhu. But just a couple of months ago, we were at PyData at IIIT Delhi. And James Powell from the PyData Foundation was there. And he said something very interesting when he was introducing Prabhu. So I'm just going to steal his introduction. He said simply that Prabhu has been around for like forever. So that's not to make him feel old at all. It's just that of all the people I know, he has dabbled in more programming languages and frameworks and platforms than others. And if Python needed an evangelist, it would be him. If Python needed a critic, it would be him. So I couldn't find a better moderator for this panel discussion. So with that, let's start.
Check. So, should we go? Okay, so welcome everyone to this panel. I'll get straight to the point. So first, thank you Jaydev for a really warm introduction. So I'll get straight to the point. So, because I think there are 4 of us, and I'm sure each of us has plenty of opinions. And I'd like to keep some space for some audience questions. So my first question is going to phrase it in 2 different ways. The first is, what is Python not good at? That's the obvious. And if that's kind of too hard to answer, maybe what bothered you the most personally would be my first question. And if you're not able to find things, I will find things. So, okay, maybe we go from here.
So what bothered me about Python? Is that the question? Okay. So it's kind of, so I only have a lot of good stories about Python, so it's hard to find. So one thing Python, bothers me about Python is it's so easy to go structureless, okay, and it hurts you in the long run. So if you look at more statically typed other languages, it basically forces you to actually have some structure. It slows you down. Whereas Python really go very fast, really not worrying about typing and all those kind of things, and in long run it really hurts. So that's, I think, one of the to be a good Python programmer, it really needs a lot of discipline. So if you're writing non-trivial programs, it requires a lot more discipline to do stuff in Python. That's what I think.
Yeah, so this was my first point as well. Once a program crosses a certain size, then suddenly you say that none has no attribute to lower or something, and you don't know why. So if you don't have the discipline, then Python, it becomes a problem. The other thing which I started feeling not too long ago was the first programming language that I did some major work in was in C. And over there's some amount of rigor, as in, like if you want to get some even a basic program working, you need to sweat the details and get all the bits and pieces right. Whereas in Python, that's not necessary. You can get 10 times that much in 1/10 of the time. And over time, I guess the best way to put it is that it makes you soft. You're just so comfortable doing this. And when there's a demand for rigor, like you don't have enough memory, you don't have enough, you're not fast enough, you sort of lost the mental tool set to assess the problem from those dimensions. It's just, it's a victim of its own, user friendliness in some sense.
I think building off of that, something that maybe isn't so much wrong with Python as much as is wrong with the people who use Python, and the way that they've all disappointed me and the way I disappoint myself, is that actually Python is a deeply empowering language, and people can get started in an afternoon and be very successful with it. And at conferences like this, we always talk about how great that is. But the downside is that it sort of selects for people who are that kind of people, who are going to go and strap themselves in and get their job done. But in optimizing itself for that kind of use case, the community itself tends to sort of converge around those kinds of people. And actually, to your point, the kinds of people who tend to go and build software systems and take a more deliberate approach and be more measured and don't try to solve problems that they could solve in an afternoon, their voices they're not ignored by the community, but their voices are proportionally less. And so it's sort of like the thing from Spider-Man, where with great power comes great responsibility. It's not always true. Python gives you a lot of power without requiring rigor, without requiring responsibility. And then you end up in a spot where you've done a bunch of stuff, and you're like, oh wait, what's the none that doesn't have it to lower, right? So I think that's one of the areas that, as Python becomes more ubiquitous, as it is one of the most popular programming languages in the world, we as a community, I think, of users and of promoters actually need to take some conscientious effort towards promoting rigor and promoting understanding of what it means to build a software system versus a script, and things like that. So that's one of the areas where I think Python has succeeded, but caused itself quite a bit of drag in succeeding.
My main problem is that Python is not on the browser. It's not on the browser.
There's Python, right?
It's not on the browser. It can be in your machine, it can be in my machine. It can't be, I can't put it on the Government of India website and expect people to use it. So that, actually, if there was one alternative that I look for Python, it is JavaScript. And for, by and large, this season, and every year we take a conscious call. Should we stick on to Python, or has the time come to move JavaScript? Because that is the largest platform, and this is my biggest pain area. Because obviously I'm still on Python, and we have taken call that we will continue at least for the next 2 years, and there's no question about its ability. And I'm specifically speaking about the data science stack. The second is that while the first is a broad concern and something that affects me on a day-to-day basis, the second is something that probably affects me about 5% of the time, which is that it's easy to write slow code in Python. For a beginner who just puts in a for loop inside a for loop inside a for loop, which is the most natural way of doing it, the result is not fast. Dictionaries now are a whole lot faster, but they're still not as fast as you could if you were to write them in C. Because it would have taken you 20 times longer and would require a great deal more experience, but it would be fast. Now, instead, if I run the same thing on Node with the for loop inside a for loop inside a for loop, it's no slower than if it were not significantly slower, which is definitely again. Functions. I can use functions, I can use loops in server-side JavaScript and even effectively client-side JavaScript without the worry. My problem is not the relative speed of Python versus JavaScript. It is the gap between significantly optimized code, which I can write in Python, and the non-optimized code that I write normally, and that it clearly divides the community into people that can and cannot, which is the problem. A third issue is a relatively minor one, and it's largely vanishing, but still not fully vanished. It's packaging. I want to distribute a Python application. I want to build an exe file and send it out. Someday I'll be able to do it. Last 10 years I haven't. Before that, until a few years ago, I wasn't even able to install the application in many systems. Now, partly thanks to you, Peter, we are, and that is a huge benefit. It's still a long way from the packaging. Finally, you know this for what Derek hinted and I mentioned earlier, Python is not Excel. It's not the tool that you pick up and explore. We're getting slowly, steadily closer to that. Should we not? It's a debatable question in the sense that there is a completely different, that's a completely different world. And Python need not be a tool for everyone, for everything. But for the use that we are increasingly putting Python to, which is exploratory data analysis, it is not meant for it. And the proportion of people that are finding this to be a pain is growing and will continue to grow. And that includes me.
Thank you for some excellent points. So I sort of build off, and I expect that again the answers go from there to the other side. So building on the same things, I'm going to pick up 3 different pain points which I found were important. The first one was, of course, Python 3 migration, which is still an ongoing issue, especially the more deeper and more entrenched your code bases. The second is, of course, packaging. I know a lot has improved, but there are obviously divided opinions, and I want you to be divided in your opinions. I want to see what comes out. Then there is threading and the GIL. That's another issue, which goes back to performance with PyPy, LLVM-based tools, other new languages coming up, Numba, the whole works. So, opinions on that. And of course, Python on the browser and things like that. So, if you could maybe pick one of, you've already, I think, said some of your pet peeves, but if you can talk about, say, the Python 3 migration issue, and then hand it back. Did it affect you? Was it a problem? Do you see that there's an actual issue with the leadership in, I'm obviously asking leading questions, right? Is there an issue where, we made a choice to go to Python 3 without necessarily understanding the total footprint of how bad the ramifications could be? I know it's a solved problem now, but it's been something that has taken a long time.
It has, and it will take an even longer time. I am the conservative guy. We're still on Python 2.7 for all practical purposes. And told the team, look, switch over to Python 3 if you can. Right? But interestingly, anything that gets deployed in Panda goes to one particular UAT server, in which we only have Python 2.7. So one day Vijay, this project, he aggressively took it into Python 3 and it is on Python 3, and I still haven't put in Python 3 on the UAT server for him to test out. So the thing is, there hasn't been a need, and more than anything else, I'm grateful for the long-term support for Python 2.7, the fact that it continues to build and so on, which is great. Increasingly, it's becoming compelling. Dictionaries are faster, async await is far more effective, and if I were to pick any 2 reasons to migrate to Python 3, it would be these 2, which only came in Python 3.5 and 3.6 by the way. So there is a reason to migrate now, more so than earlier. There isn't a compulsion to migrate. When the time comes, I guess the reasons versus the costs, obviously the costs are high, but that's not because of the nature of the language, it's because of the existence of a large code base. Once the reasons are compelling enough, people will migrate, we will migrate. I don't see that as a challenge as much as an ongoing issue. The good part is there aren't bottlenecks in that, external bottlenecks. The bulk of the libraries work on Python 3, and the bulk of the ecosystem has support for Python 3. So there's no problem that I see. GIL, on the other hand, is an interesting one. So, well, as Node has also shown, event-based systems are working quite well. And maybe there isn't such a strong need for going in for this, but event-based systems are also not intuitive enough. The way of code is a much better model than the callback model. But even then, it's not intuitive enough. I don't know, but this is a gut feel that if we make the event-based systems good enough, easy enough, I don't know, more pervasive perhaps, that the I/O module, for instance, the networking module, all of these are async by default, and perhaps without even needing to specify async and await. And that's how it operates.
But the problem, of course, is you have to have a buy-in, right? If you're async, you have to go all the way async, right? So,
Yeah.
so there's, it's a slippery slope. Not even it's a cliff, basically. You go off a cliff, completely off.
But the GA is not going to go away.
Right.
So,
But on the flip side, anyone who's done threaded programming at a deeper level actually appreciates the value of the GL because it saves your real almost every single time.
that is true. That is true. But I can tell you that GIL is popular, and XFL is helping a little bit at least.
So before you hand off, just one more question for the entire, just in the same theme, is one thing that I have noticed across the years, way back in 2000, there are so many plotting libraries, and the damn thing doesn't change. I mean, the day you started, you say, hey, I don't like this one, I can roll up my sleeves and write my own plotting. I've written my own plotting library, and I'm not going to mention the name of that library. But there are enough plotting libraries, and people are still coming out with new plotting libraries. Every day there's a new one that has this time awesome feature. What's your opinion on this? I mean, is this a problem for a beginner? Is it a...
Can I add one thing? Okay. Earlier, like a couple of years ago, people used to say Python has more web frameworks than keywords. Now I guess we're saying Python has more plotting libraries than keywords.
Yes, so I think it's again a victim of its own success in that sense. But again, do you have any
I have to shamefacedly say that it started off one this month. But because we need one, nothing is working, and what we'll build this, we'll throw it away. Know that. But the thing is, we haven't reached the maturity of, for example, on the web frameworks, knowing what is working, what's not working. People have to try it out. I'll tell you our history. We started by saying, okay, let's have charts. There is a grammar of graphics, which allows people to construct charts. But let's start with the charting library that helps. It worked great. Where did it fail? Interactivity. And creating it on the server side. I need interactivity. Therefore, it needs to be more browser-based. Second thing, and then therefore we say, okay, maybe it's time to shift to JavaScript. The second library that we built, that was on JavaScript. And we said, why should we restrict ourselves to predefined charts? We will make it arbitrarily extensible. And in the process, we allowed everybody to create all charts, existing and new, with equal ease or difficulty. And it turned out that creating simple charts was a nightmare compared to what it was earlier. So, big problem. Now, third attempt, we know that we want two levels of abstraction. One, which makes it easy for people to use simple things, and secondly, also infinitely extensive. I'm sure we'll come up with something that is a problem. I don't know what we
And the other issue that I find is, often everybody's running off with the web, and I write a notebook, but then I want a PNG.
Yes.
And I don't want to fire up a browser to get that PNG. So
I
that's
mean,
again,
I mean,
I know everyone's working towards that, but...
Absolutely. And the combination of vector and raster as well. I need other vector formats. I don't want a PDF with a PNG embedded in it. I want a native vector graphic.
Peter,
Are you trolling me or are you serious with your question? I think, well, there are so many questions there. I'll start with the plotting one, because that was the last one you asked. Plotting is one of those problems that it is incredible. The world of information graphics was non-existent up until 400 years ago, and then it was very static up until about 50 years ago, and then has so much research, but then all that research is very niche, and the actual charts and infographics that we see today is actually a rich innovation area. So even if you look at grammar of graphics, or if you go even earlier than that, you look at Bertin and semiology of graphics, and you go through the theory underlying how humans iconically perceive data, or perceive visuals that are correlated with data, it's an open area of research. And so to even know, if you had the most amazing alien rendering, plotting, charting, graphing, whatever, to ask it what to represent or draw for you is an unsolved problem. And then you try to build software frameworks around it, and then you try to target those frameworks against everything from PDF to various kinds of vector formats, which are incompatible with each other and have small rendering differences. And then you want to do it in JavaScript across 5 different browsers and 3 different platforms, one of which has 12 different distributions. And then you want to work on 95 as well as 98 as well as, You end up with basically a hard software problem. right? And the reason why plotting in particular has the this anti-pattern you talk about, where everyone writes their own plotting framework, is because for your particular vertical need in plotting, you can see the route to the right answer for all of those things, and you can ignore, you know which things you can ignore. People who want to build frameworks for this stuff immediately run into the whole set of problems with it.
And it's a long tail.
And it's not a tail, it's just flat. You just solved your sliver of it, and then there's the rest 2,000% to be done. So I will say though, since you trolled me with the question, I will advertise that with Bokeh, we do have this kind of two-level scheme, right, where there's a low-level library and a high-level library. And we did target the web natively first because we wanted interactivity in the web, but we did that by writing a JavaScript library and a Python library. It's 2 in 1. And then we do have SVG export as well as PNG export and whatnot. So we really try to solve the intersection of these different problems. But the work is not done, right? It's still plenty of work to be done. Relative to GIL, packaging, optimization, threading, and several of these other issues, the big underlying question that has to be answered, I think, is what do we want from Python? Why do we care that it doesn't run in the browser, right? Why do we care that I think Python's packaging story certainly is no worse than NPM. And so yes, you can write 3, 4, 10 nested for loops if you use the right braces to get your scopes right and set this equals that or whatever. You do a JavaScript to make it work. But then, you have to go and package it, and you have to make sure that npm.org isn't down or js.org isn't down, and then, the whole thing is its own pile of fails. So I think at the end of the day, we have to ask, what is it that we're trying to get out of Python? And I don't mean that just in that's obviously a very flippant sort of question, but right now we're at a time when the software industry is changing, right? Because if you look between NPM, say JavaScript on the server side versus Python on the server side, even if we didn't have threading in Python, what is the JavaScript doing? It's pulling something out of a database, probably Mongo, right? And it's going and writing some kind of HTML out the front door. And if it's slow, or if it's fast, you're going to use some serverless infrastructure, spin up thousands of little spot instances to respond to need. So if you look at optimization, if you consider Amdahl's law of accelerating the thing that is the biggest bottleneck, for most applications, web applications, the bottleneck is waiting for I/O. And then if you go to scale, the cost for you is not dev hours, but it's the CPUs that you pay for sitting on the cloud that are not getting used. So if you consider the full end-to-end optimization problem, you say, where does Python fit in all this? My view, and I have a particular bias because I'm trying to solve the data analysis problems, my view is that we should optimize for bringing the most number of people in to doing computerish things at all, right? And the world of, I think, software data scientists, it's about 3 million or so, 3 to 5 million data scientists. Actually, it's more than that, but somewhere in the order of 5 to 10 data scientists. There's tens of millions of software developers in Python, Ruby, kind of in these dynamic languages category. But there are hundreds of millions of Excel users and advanced Excel users. So I think if the goal is to get computing democratized for everyone, we need to look at the broad spectrum of things we need to do. And it is annoying that the GIL slows us down sometimes, or that deploying DXC is very, very difficult. But at the end of the day, if we're trying to tackle little language features, we have to ask, is that the high order bit that we need to flip?
I'd like to talk specifically about the packaging thing. So I think for the first PyCon which I attended, first time I was attending a dev sprint and I looked at all the things there. I thought, packaging, that looks simple, I'll go there. And I went there and all these, at the time it was doing the distribute set of tools came in. So I sat with all these chaps and they were talking about it. I thought packaging is if it's OS level stuff, it's apt-get install or something. If it's C, it's configure, make install. Those things work. And then there were people from Debian, there were people from Red Hat, there were backward compatibility issues. And also Python came from that batteries included kind of culture. Whereas right now languages are very lean, right? You get just the language and you install the rest of the stuff. Whereas Python at that time, I guess it was because of the internet at that time. You download Python, you get everything. So then all these people had to, make compromises and somehow get this thing to work. And more or less got it to work. I think every package manager is broken in a different way. So I went for a conference once and for a workshop on some language, and the the author of the package manager in that language was doing the workshop. The package manager broke on my laptop and he didn't understand why. So it's all broken. Yeah, I mean it's a hard problem. Like I forgot who. I think Dave Beasley said that he should call his package manager maybe. So maybe install this. Maybe upgrade that. But the thing is, we had this problem in a couple of companies where I worked, and this was pre-Docker. And our solution was to actually get the packages we want, apt-get install everything we want inside a chroot, and then make that into a self-extracting zip file and just put it over. You run it, you get a mini Debian with everything inside. And that was sort of a pre-Docker container kind of thing. And I think that's going to be the way it move forward. You just put everything together and ship it out.
Apple embraces that whole thing.
Huh?
It embraces that.
Yeah. I mean, like the specifics about if I say pip install this or conda install that and environments and this and that, I just put the whole thing together. There's issues of size, yeah, but I mean, it solves the problem for most of the people. So I think that's the way it's heading.
Can I disagree with that now or later? You speaking that, I can respond to that maybe. Sure. Oh, okay. Well, I think we have to be very, very deliberate in distinguishing between the self-integration and self-deployment versus distribution are two very different things, right? And when you talk about putting everything together in a Docker or doing a zip file to mirror your development environment and put it in production, you are deploying your own software to a system you control. Distribution, as defined, like the problem definition, is just deploying software to other people's computers. And if someone else's computer is a corporate Windows machine that will never run Docker, right? I mean, that's the kind of problem that we have to solve. And it is absolutely an unsolved problem. The largest software company in the world, Microsoft, has not solved this. They ran into shared library problems. They had to put Windows side by side. They had to basically move themselves past the DLL hell problem. It is an unsolved problem in every which way. And if you look at Red Hat, which is the most popular and certainly the most commercial Linux distribution, internally they're realizing that system-level package management is not the same as user-space package management. And most significantly, the kinds of data science workloads that people are bringing, where they have the lean languages and package management from Node, right, or Ruby or whatever, people are loading modules and libraries in and managing packages in a way that's fundamentally different than how people might have said, oh, well, this month I'll do a glibc upgrade, and I'll be good for 2 years, right? And so the nature of software itself has changed, the nature of deployment has changed, and actually, to some extent, the world's gotten more heterogeneous. That we have Mac and Windows and Linux all needing to interoperate much more now than was the case, I think, 10 years ago. So I think, but nonetheless, fundamentally, the container approach is only solves that deployment problem, not the distribution problem. I just want to make that point.
So I would like to talk about 3 different points here. Talking about so one thing I want to talk about the GIL and concurrency and the plotting libraries. So before that, I want to talk about this part where so one of the things when you look at Python is like Lego blocks. Okay, you can just start building things pretty quickly. And it starts hurting you when you actually start building the capital. I mean, you can start building a small toy in a couple of minutes and it starts moving around and you can actually with just small bits and all that. But if you're really trying to build a real production system which is really large, then that's when things start going brittle. So you need some kind of tools that help you. For example, you're building data structure which is not a simple list, but list containing a dictionary that contains a list of something or something. It becomes too hard to actually keep that information across different modules, etc. So that's when having some kind of typing really helps. I think Python 3 is solving that with having optional type hints, but that's not mainstream yet. Until that becomes mainstream, we're going to suffer that kind of problem. Until people in the community adopt that heavily, we're going to have this kind of issues in the Python community. But I hope that will actually address that thing pretty well. We'll be able to build solid systems with very good type checking and making sure things are not breaking, etc. The other case where I think Python hurts a lot is concurrency part. Okay, so while threading is good enough for most needs, even when things are IO bound, you don't really have that kind of flexibility that language like Erlang or Go offers. Where you can say I have one process for everything that I have. So while you can do it in Python, but that doesn't really come very naturally with Python. So if you're doing something with Erlang or Go, you can say that I'm going to start a new process or a Go routine. So every kind of task that you have will start as a new process, and that's not the kind of thing you do in Python. You start judging, is it good, is it going to hurt my JL? So you have to actually judiciously think about each and everything before you actually make those kind of things. So that basically makes that people don't do that often. So that's one of the pain points with doing concurrency stuff in Python. The second thing is error control. So when you're building these kind of multi-threaded programs, it's very hard to figure out if one thread just throws an exception and fails out. So those kind of things happens, and then it's very hard to find out why that has happened. But if you look at language like Go, doesn't have any exception handling, you actually have to get the error code out and then basically check what state is. So that kind of makes, those kind of things are probably good for building system programs. Maybe not, but I kind of get that kind of feel because I've been like burning my, been writing those kind of system programs and then with Python, and then I see those kind of issues these days. I think having some kind of more rigidness like Go, etc. would probably help, but I don't see anything like that in Python. So, and come to the plotting libraries. I still, so I run a startup for scientific data, platform for data science. The first thing people ask is, can I do something like R, like a shiny like R in Python? Unfortunately, the answer is no. Okay, for a very simple dashboard in Python, there's no option in Python. You can do bokeh, but it requires, it's too verbose, you can write a lot of code. It requires a lot of code. So people say, I know I can do this, I know how to do it, I can do it in my notebook. How do I get it on the browser as a dashboard? It's really hard problem, unsolved problem. Okay. You can do something like Dash, which is kind of new, but still, that requires a lot of verbose code still. I think the problem in most of these libraries I find commonly is when you try to optimize a library, do you optimize for the power, how much you can do with the library, or how simple the interface is? You have to make a choice. And most of the time, the Python libraries tend to go in favor of having more extensibility and more power rather than the simplest API possible. So that's why, like, if you look at any of these libraries that are in Python, they're easy enough, but not really easy for someone to just get started and get some dashboard out pretty quickly. I hope I've been like thinking of adding one more to the list of plotting libraries so that they can actually do something like shiny and R.
Okay, so in the interest of time, I'm going to ask a couple of questions, and I'd like you to keep your answers to like a few points that you think are most important. Again, you can go from this side. One is, where would you not use Python? 2 examples or 1 example. And 2, how can Python be improved in terms of what other language feature that you think might be useful? Maybe 1 or 2, if you have. So first is, where would you not use Python? Second, what language feature do you think, if the BDFL was there, I'm going to grant you your wish today, what would you ask?
So need some time to think.
So many of the projects which I've been currently doing interface with hardware a little bit, and there this thing is not an option. So you have to write at least some parts in C to get them to work. But there's a savior there, which is FFI. So I've been using CFFI a lot for testing, for interfacing. It's really a godsend. C extensions by hand are not an option anymore. It really works for me. So that's one thing. Features which I like in Python, static typing, at least optionally. And not just as a feature, I'd like more people to use it and it becomes sort of the community standard.
Yes, I guess I think I'll take the last.
Okay, you think it will end, so you can go.
Okay, so where would I not use Python? I mean, you can't use it on mobile, right? So I wouldn't use it where I can't use it. I don't know. I mean, I don't write mobile apps, so I wouldn't say it's a strong desire. I think, you know, in terms of any kind of realistic system, there is a footprint issue with the Python runtime, and this ties into the feature I would ask for, is getting, you know, some of the Go or Nin or some of these other kind of newer languages that have, you can switch from, well, maybe not with Go, but you know, you have the option of actually choosing when to pay the cost for garbage collection and when not to. And that ties that embeddability and the smallness aspect of it. It is not easy to have really Python embedded in other systems and languages, and it makes it hard for interop with some of these things. So the solution, however, I think is not necessarily, I mean, by the time we solve that problem in the language, the ship may already have sailed in terms of what we would do with it. So that's sort of a nebulous answer, but I think the big thing is making Python itself more, just smaller, more nimble, leaner, yeah.
So I'm seeing most of you are leaning towards a more static, maybe a core R Python-esque thing that is a more harder version saying statically type, leaner, meaner, where you can control.
Compile the one executable, you know, kind of thing. Something along those lines. Because if you think about why are these things hard, they're hard because of that power. The power of Python, the CADI, the power to natively expose Python objects. There is a C API for Python itself, right, that you can write things to. That's given it great power. That's one of the reasons Python actually uniquely among any other language has long time survivability into data analysis and science and engineering. But that also comes with a cost that we don't necessarily always want to pay. The one thing I would ask for, if there was something I would ask for, and it's actually not come up at all in this discussion, is that most of the real business world, business data systems run in Java or .NET. And at least .NET, you have the CLR, DLR, but Java and Python, the two of them don't really get along very well. I think the Arrow project will make improvements in that area where it matters. And then the rest of Java that doesn't store data off heap in Arrow will just be more like a node thing or just some little fast business database manipulation bits. But all the meat of what needs to happen in terms of the data analysis side and the CPU intensive stuff will be in a more interoperable Java to Java Python area. So the language itself could probably improve by adding some like improvements to memory view that allow for this kind of interop, like a NumPy++ that works well with Arrow.
I wouldn't use Python for interactive visualization still. I wouldn't use it for distributed computing either. At least I don't dedicate that to a Spark or AWS kind, at least when it comes to data. Probably could do it, but no, I wouldn't.
But you would still use it as a glue to drive.
Yeah, absolutely. So sitting on top of it.
Yeah.
But if I needed something that absolutely had to run across multiple systems, Python is not my first choice. What I ask for, if we could get the GUI library standards, Python standards, I would love that. It could be something like Electron. Electron's great. Known technology, but native for all practical purposes. Writing a GUI program in Python is a non-stop.
PK Intel is still the hidden standard which nobody uses.
It's unreal.
So one thing, I really use Python for almost everything. There are things which really has like spirit computing, etc. I think so. That's what I really want to be somehow fixed. So you can do async, but that requires you to start a unit loop and then make sure that you're doing only IO-intensive things and never actually hogging CPU for a long time. So if you can magically have something where you can actually don't have to think about those things and the system kind of takes care of that. That would be really nice. For example, you write a program like Go, start a Go routine, and then that starts running. You can actually have something like that in Python. That would be something that I would really love to have. And if VDFL can somehow grant that, I'll be very happy.
Yeah, I was just going to ask, what, for the distributed computing, what would you use and why?
I would just go with AWS. Yep, the bulk of the distributed computing that I need is data related. So any database, I include Spark ecosystem in that track. And the complexity of the bulk of the computing that we do in a distributed way is not so complex that it cannot be encapsulated into a program that runs on Spark. That is enough. Having said that, I haven't yet faced a problem where I need distributed computing for something like, let's say, a network problem, in which I'd rather write the code in Python, perhaps, and still have it run. That's a valid use case, but niche from
When you do Spark, you would do PySpark, yes? Okay, so you're still using Python.
Yeah. So that's what I was saying. So you have to sit on top of Python, but at the low level is not wanting to use Python at the low level, which is kind of
As a low-level driver for
yeah. So for example, I would want to write API in Python.
Right. But you would do Dask anyway, so.
Yes. In case of harder scientific computing, there is in that case probably you want a low level API. Yeah. CIM or something else. Then it's a lower level that you want to drive sitting at. Like, that's what I understood from his sense.
And there are small little niche use cases where Spark is too heavy. And I still need it running across multiple systems, in which case there isn't an option. That's the problem that doesn't exist. Nothing wrong with distributing on databases, that's what they're meant for.
Okay, so we are kind of out of time. I had one more question, but I think I'm going to just leave it. The question was, what does the Python community lack? I think it's an awesome community, so I think we can all agree, perhaps, on the fact that Python could not. But I think we can have a couple of questions at least from the audience.
Yes, just a quick announcement from our sponsors before we begin taking questions from the audience. Our partner sponsor Hypertrack is hosting a hackathon. It's an overnight event. It's going to start today. It's going to last till tomorrow, and there are some really attractive prizes. After the Q&A round, is Ravi here? Yeah. So Ravi from Hypertrack is going to announce the hackathon and tell you more about it. So,
Yeah, questions? So please try to keep your question a little short so that everybody gets it.
Where should the future of Python go, and where do you see it going?
If anyone can
So I think I will answer the question directly. So I'm from a city called Vizag, a small city, and I went to college once, and they told me that TCS came and hired some 600 people from the college. Okay, and the executive told me that TCS asked all of them to learn Python before joining. Okay, so you know where the future of Python is going.
So I think that right now, many of us come from programming in a time when there's a lot of general purpose programming languages. And I think that as computing continues to spread and go more pervasive in our lives, there will be more niche sort of optimization happening, niche evolution. And I think Python, from what I can tell, both on the newcomers coming into it and why they're coming into it, and where it's excelling compared to other things, I think Python will continue to specialize in the data science, data analysis, science engineering, predictive modeling, that whole area. The fact that Python can actually embed onto ARM and IoT kind of things means we can put machine learning and prediction at the edge and not centralized in the cloud, and that will further cement Python's future for predictive modeling and machine learning, AI, things like that.
Yeah, I think I think the future of Python is in its one of its earliest promises as a glue language. And so I think the emphasis should be on writing standards or interfaces that allow you to communicate with things written in other languages, so that you can leverage strengths from different places. C has its strengths and weaknesses, Java has its own strengths and weaknesses, etc. And sort of put all those things together using whatever, RPC, FFI, REST or whatever, and you somehow get all those things running together. You sort of orchestrate all this in Python. That seems to be a promising way to go.
Yeah. Actually, we are in process of developing ERP for university, a kind of university management system. So, will you advise Python to develop web application for university management system?
No.
So, because there is one aspect of development where we need expertise for over 2 years at least, and second one is we need expertise for 20 years to maintain the system once it is deployed in use.
So I can answer that. So there is an open source ERP software called ERP Next written in Python, actually done by an amazing group of people from Mumbai. You should look at that.
Please don't develop. Please don't develop any language. Use something that already exists. And if it doesn't exist, live without whatever features it doesn't have. Don't develop.
So this is a question that sort of mixes the whole idea of mentoring and teaching with the problems that we already established that it needs a lot of discipline to write Python for large systems. So in your experiences, how can the mentoring and training that we do, like how do we manage the mentoring and training in Python, let's say in your view, to instill that sort of discipline and like bring up people who do not mess up your large code bases?
It starts with choosing the right variable names. It starts with picking the right variable names. So I do Python trainings, and every time I do Python trainings for people who are experienced, like 3-4 years of experience in programming. Okay, I always spend a lot of time telling people, please name your variables right. Okay, the discipline starts from that. Okay, I mean, name the variables right, that it actually makes sense what it's actually intended to be. I think it starts from there. I mean, it goes a long way from there, but I think that's a starting point.
So I think here Python's thing is the speed at which you can develop with Python, even if you're a newcomer, starts to become a liability. So I think it's a good idea to somehow encourage people to put their foot on the brakes for a while. Like think about what you're doing. Like imagine what will happen if you code it this way. Like, write some tests. Sort of use your API before it exists. See what's going on, and then so that they have enough time to make some mistakes upfront before investing time and, more importantly, emotional attachment to the code. Because once you write it, then it's your code, right? You can't change it. Right? So that kind of thing. So I think slowing down a little bit is one way to do it.
Yeah, actually, I would say that it's not any different than teaching people to be good software developers in any other language. It's just Python, you can go a lot faster and get a lot more done, and you get addicted to that, and it's fun. And you can basically create a lot more technical debt faster than other languages. Because in other languages, you're forced to do things more slowly. And in general, you're forced to, because they're more verbose, use large libraries, work with teams to just get more code churned out that actually compiles, et cetera, et cetera. And so I think in that, the key thing is to just encourage people to be thoughtful about the actual software engineering. And the real hard part about software engineering is realizing that it's mostly a human communication problem, not getting the code to work. And that's the thing that in any other language, just getting the code to work is hard. In Python, that's actually pretty easy. Knowing why it broke is the hard part, right? Knowing why it broke 6 months after you wrote it is the hard part. So communicating to yourself and communicating to other people, naming variables appropriately, that's the first step to actually having empathy with yourself and with others to develop good software.
Another thing related to writing good variable names is good commit messages. Oops fixes that, passes all the tests, yay. These kind of
bug fix typo.
Quick question. Hi, up there. Yeah. I have an application to write which uses OpenCV video analytics, which basically analyzes video. Now, that can be written in C++, and of course, that's a traditional way of writing that. And it runs on the edge, mostly on embedded devices. That's one way. The other way of doing it is using Python, and there's a lot of Python interfaces interfaces with OpenCV as well. Again, the question is choice of language. Given the fact that IoT embedded devices are increasing in processing power, one, connectivity is increasing, bandwidth is increasing, plus cloud computing is also increasing in strength. So, choice of language given these facts for video analysis and OpenCV.
I missed the last part of that question. Can you repeat that again? Maybe a little bit louder.
Yeah, so choice of language, C++ with OpenCV or Python with OpenCV, given the fact that embedded devices, computation power at the edge is also increasing, bandwidth of embedded devices communicating with the cloud is also increasing, and you have a lot of tools on the cloud as well. So, the choice of language between Python
and I think I'd add one more piece there. C++ is also getting better.
C++ is getting quite good, actually, in fact. It's just which C++, 11, 14, or 17? No, we literally just had a regression in the latest Anaconda. Well, not a regression because it didn't make it past the release test, but we realized that Microsoft, whatever, Service Pack 3 for VS Code or something, or Visual Studio something or the other, broke support for something or the other. I don't remember the details. But, and then like some OS 10 update, its version of compiler doesn't support whatever. So C++ is getting better, but it's almost getting better too fast. So anyway, but to your point, I would again encourage the question to not so much be about which language as much as what is your application, right? If your application is to do some kind of prediction and that prediction sits at the edge, if the bandwidth of the analog world to the digital world of that chip is going to be relatively constant, and the increased bandwidth between the chip on the embedded device and your cloud is then increasing relative to that, then I would say that, yeah, it sounds like you don't have a bandwidth problem. But if, as the bandwidth gets better, your chip gets better and better, or you have more capabilities, or you integrate, 3 different kinds of additional data streams along with the video to improve the prediction, guess what? You're going to have richer models. You'll want to do deeper kind of training. You're going to want to deploy, TensorFlow things out to the edge. And in that case, you're going to want to have the agility of a language like Python. If you can know right now for your application domain, I know I only need this many, this much quantum depth in the CCD wells. I know I only need this much whatever. I only need to sense at 2 frames a second. If you know your physical problem is well constrained relative to the bandwidth changes and the CPU changes of all the hardware, then pick the language that's appropriate for that.
What's the last question?
So I think we'll have to wrap up. It's lunch is getting cold, so and of course we have a message from Ravi from Hypertech about the hackathon. Again, it's an overnight event. Just find him at the registration desk later.
So let's thank our panel for a really nice.